Okay, now we are going to discuss about another JavaScript concept, which is variables, their values and references. It's common confusion point for most people how JavaScript variables are passed, whether they are passed by value or whether they are passed by references, and that creates a lot of problems specifically for people who are coming from different language background. So one thing that you can always remember is that everything in Java is passed by value. That's it. There are conditions which we are going to discuss, but everything is a value. That's it. So condition number one, when variable is an object, that value is actually a reference. So let's start with an example. So let's say x equal to 6. So what is 6? 6 is a value. So somewhere x has a memory allocated which holds value 6. So that's our variable. So let's say you defined x equal to some this, let's say an object. Okay. Now here what happens when you assign an object to a variable. So this is an assignment. So if you had declared x simply x, let's say, that would have created allocated memory for x, but with null pointer. But when you assign and when you assign value like 6, then it would have just had a value at that memory location. But when you assign as an object, what happens is it assigns it allocates memory for this object, number one thing, and then whatever is the location of that memory, that is referenced to this variable called x, and this happens for this as well. So what is value of x? As we said that JS always passes by value, and here we definitely have some value. For a variable we must have some value. And what is the value of this denotation? It's a memory location. It's a reference where this array might be stored. If we say this, then whatever this array is, wherever this is stored in a heap, that reference to that memory location is stored in x. So it's just pointing, x is just pointing out to this array, right? And okay, now let's say you assign this variable x equal to this object, and then x was this object, and now we changed it to array. What happens is that it does not change anything. It does not change whatever object you had. It does not change that. It changes just the x assignment. It assigns a new reference to this value, to this variable. That's it. So it's simply pointing out to this array now instead of that object. Got it? Now, changing property of an object referenced by variable does change the underlying object. Now we come to change. So you said x equal to array. So array, if you are confused, array is actually an object. So that's why I'm interchangeably using object and then array for things. But let's, for the sake of simplicity, let's say x equal to this. Okay, and b2. Okay, now x has memory for this location, right, as we said. Now let's say we talk about a. X a is 1, right? What if you replace that with 2? Question is, will that change x? And the answer is definitely yes, it does changes. So whenever this variable had this object reference, and then you changed this object's value, and it's done, right? it's changed. So this is also another thing. Another thing, going one level deeper. So let's say x, so let's add another object. Let's see xc equal to 3. Now x has x3. Oh sorry, I wanted to do this. I wanted to have 1 2 3. Okay, so I'm assigning an array to another property of this object. Okay, now how does x look like this? C is an array of 3, right? You could have defined directly by C array and like this, x equal to something like this, and then C array 1 comma 2 comma 3, right? Now what is xc? It's clear. Xc is this array, right? Now if you change xc, now you know that underlying object will change. If you change x, anything, if you by referring x you change something, then it will change. So if you, let's say, assign something else, then it will be assigned. Let's say you assign 2 comma 3, so then this array will be replaced by this one, right? But what will happen then when you call inside this? You go inside this, you, let's say, add any value. Okay, so let's say fourth value, define 4. Okay, how does things look like? So instead of, so if we added at 4, so that's array has been updated, right? Yes. And what is C? C is referenced wherever this array is stored. Got it? So this will come into picture as, let's say, assigning, we have another array, let's call it y, and we said we want to copy this array. Now what is xc? Xc is reference to this array, so this array reference has been copied to y. Now let's say you push another item which is 5. What happens? Y will change, true. Question is, will x change? Because you changed y, not x. What will happen here? And the answer is x will change as well. And why does it happen? This the answer is in remembering that when you assign an object to a variable, its memory is, it just says that this is the memory of this object. So whenever you assign xc, what was xc? Xc was this object. Array is also an object, as I told you. So you said y is actually memory of this array, which has been pointed out by C as well. So if y changes that memory location, then whatever C is looking at, that is also changed, which is why when you change y, xc is changed. So that's about variables, values and references. One thing out of this discussion I discovered is that const, a few keywords, const. So const is something that cannot be changed, that cannot be reassigned on reassignment. So let's say you did this, so we can declare, okay, so I decided that Z is 4 and then I say Z is 5, it will give you an error, right? This will update. And but let's say const Z, it won't happen, right? A, let's say a comma 1, let's say 4,5. Okay, now will I be able to assign another array? No. Will I be able to push an element into it? And the answer is definitely yes. Why does it happen? Again, same, this is just a memory reference, and we are changing that memory by doing this, right? Okay, reassignment, no reassignment for const. How do you so you can mutate the object. So if we go into keyword, we were able to mutate the object a, right, which was a const, which was defined as a const, right? But we cannot reassign. Now there is let's say we want this, we don't want to mutate this object, right? How will that happen? So that's where comes object.freeze. So we say object.freeze a, and let's try to push another number into it, and then this will throw an error. Again, this will but this doesn't let's say if it had been something like this, like this. Okay, so b would have been a nest. So this is an object, and inside this another nested object, this array. Now it wouldn't have thrown error here if we had tried to change b, right? Because it's an array inside array. By applying all the principles that we discussed, we can say that even after freeze, it won't be possible to mutate this nested object. We won't be able to mutate a, we won't be able to reassign b dot a, we won't be able to reassign b dot b. So whatever array that we are referencing to, so let's just do this const a b. Okay, so b dot push, let's say b dot push 1. Okay, we have it, right? And now we do this constant dot freeze and b b dot a, we try to, let's say, do it b dot a equal to 2. Did it change? No, it didn't throw an error, but it didn't change as well. So that's something new for me as well. It should have thrown error, but anyway, b you cannot mutate this, that's one thing. Now b dot b, let's see, can we update this 5,6, and let's see, nope, it's array of 1. Now let's do this dot push, we are going to push 2 inside this array. Will that change? Definitely yes. It's a nested object. Object.freeze does not control nested object, it's only looks at immediate child of an object. So this is about object values, variables values, and references. We covered objects, everything passes, brief is everything passes by value, and we can change value of a variable if it is its underlying primitive object by just referencing the variable. And changing property of an object referenced by variable does change the underlying object. So that's about it. Thanks a lot for